Hello guys, welcome back to day 10. I might have done little oopsies and forgot I had a video due today. So we're gonna hit up a probably easier question. I've been dodging apples and oranges. Let's not dodge it anymore. Type shit. Hold on, let me check this. Sam's house has an apple tree and an orange tree that yield an abundance of fruit. Yap. We don't. Okay, so they're just saying, using the information given below, determine the number of apples and oranges that land on Sam's house. This is between S and T. So the red region denotes the house where S is the starting point and T is the end point. Okay, so the apple tree is to the left of the house, and so the apple tree is here and the orange tree is here. Assume the trees are located on a single point. So a single point A and B, yeah. Where when a fruit falls from its tree, it lands d units of distance from its tree of origin along the x-axis. Okay. Okay. So it's d units from that position. So for example, from A, it's going to be, let's say 4, it's going to be plus 4 relative to A. And from B, it's going to be minus 4. Because, you know what I'm saying? When fruit falls distant along the x-axis, a negative value means its fruit fell d units to the left, d units to the tree's left. Oopsies. And a positive means to its right. Yeah, it makes sense. So then, I'm assuming we're given a list. Let me just. Are we even given a list? Okay. So, given a value of D for M apples and N oranges, determine how many apples and oranges will fall on Sam's house. So it has to be in the inclusive range of S and T, makes sense. For an example, Sam's house is between 7 and 10. The apple tree is located at 4, and the tree is located at 4. Oh, okay. I'm going to open VS Code in case. So, if the apple tree is located at position 4, right, and the orange tree is located at position 12, and there are 3 apples and 3 oranges, and they give us a list of where they are. So let's say it's at 2, so that means it's 2 from the right of A, so it's going to be 4 plus 6. 4 plus 2, which is 6. Another one, which is going to be 3, so it's going to be 4 plus 3, which is 7. And 4 minus 4, which is going to be 0. To the left. Units, distance of A and oranges. So they gave us a list of oranges. Adding each distance will give you a list of distance. So in this case, when we do 4 plus 2, it's not within the range, so it's not going to count. But 4 plus 3 is within the range, so it's going to be 1 apple. Yes, makes complete sense. I get it a little bit. Adding each distance. Okay, yeah, you just gotta do the math yourself. 1 apple and 2 oranges land on the inclusive range, so we return 1 and 2. Okay. So, they give us S and T. So, interesting. Okay. So, what makes it? Let me clear this. So, what makes it that an apple or an orange is within the range? that means that the value, its position, so its position, let's say for example it's an apple, right? Its position, oh, I'm going to terminal. Its position needs to be inclusively in between, so 7, let's say in this case I think it was 12. I'm pretty sure no, it was 10. But it doesn't matter, all right? Let's say S and T. It needs to be exclusively between S and T, which can be checked with an if-else statement. All right. So for it to be within the range, it needs to be within the position X needs to be between inclusively S and T. Now, what is X? That's probably when it gets the most important part of the actual algorithm. We need to determine what X is. So X, we have a list of apples, and they're just integers, positive or negative. Positive meaning it's to the right of it, so we're going to add towards it. And adding towards the right of something, so we're going to be doing the integer value of the position of the apples tree, and we're going to be adding that integer or minusing that integer depending on its sign, obviously. So this seems pretty simple. I'm going to code it on here because I feel lucky in here, you know what I'm saying? Oopsies. So here's a list of things, right? So we have S and T, and we have A and B, in which A is the actual position, B is the position. We have a list. So we want to go through each element of the list. So we're going to do for I in. So we want to go through each position inside of the list, or I can go through each value. But what the thing is, we want to keep a counter. So I'm going to say over here, apples. Oh, oof. Apples and oranges. I can say X and Y, let's say these are apples and oranges, is equal to 0 and 0. These are going to be the counters because I want to count them, right? And if all of my conditions are met into determining that the fruit is between the house, between the two ranges, then we're just going to add up a point. We're going to increment a point or increment 1 into the variable. So for I in, I don't think it matters too much, but I'm going to say in range, the length of, let's say apples. Let's start with apples, all right? A should be the list. Oh no, apples is going to be the list. So A is just a position, all right? So we are going to do position is going to be equal to, let's say the that value of apples plus the value of A, right? Because effectively the position that the apple's at is either it's gonna be like a sum, right? It doesn't matter if A is negative, because if A is negative, it's gonna just cancel out with the plus over here. So we're just adding the position of that number that's in this list of positions of apples, and we're adding that either to right or left of it, and that's going to be its current position. And now that we have its position, all we need to do is make an if statement. So if the position, if position is equal to or less than, so it's either or. So let's say it's equal, let's say position is greater than but or equal to 7, or position is is position what's it called? Is it 7, greater than 7, and less than or equal to 13? Or in this case, it's actually the coordinates. I actually lost it. So S is a starting point, so it cannot be less than, it can be less than t. So if this is the case, then we're just going to do x plus equals 1. And that should be it for that variable. Just making sure we're trying to return these 2 points, right? So I'm going to do 4j in range. Length, it's the same exact thing. I'm not even going to like retype all that, to be honest. I'm just going to go, yeah. And I'm just, this case is just going to be oranges. And we're going to increment for oranges, and we're going to add it to the vector b, the position b, and we're going to compare it again. And the only difference is that we're going to be incrementing the y value, which is going to represent the oranges. And now we should just return x and y. My only the only thing I'm wondering is these two enters thing. So let's just review everything and make sure that we're right. So we have a inclusive range of s and t, and we check that. And we know that the position, just to clear up my thoughts, position needs to be greater than or equals to, so it can be further to the right or equal to its s position, but it has to also be less than or equal to the t value. So that seems right to me, at least at first glance. Now we are taking the position and we're adding the certain number in that certain index, and we're adding it to a, and we're checking if that's the case. If it isn't, we move on. If it is, we increment it by 1. And by the end of it, we return. Okay. Now, this is just 2 examples, I'm assuming. Actually, there's a function description. Yeah, we know this. So A and B are the positions of them, and apples and oranges is the list of them, and S and T is the other positions. Okay. And we're given a constraint. We're giving a bunch of sample inputs. I don't think I need to stress too much about it, but for the sample outputs is the only thing I might be a little worried about. Just because I don't know if I'm supposed to like return it like that. You know what I'm saying? Alright, let's try it. Things never go right the first try. So I didn't. Am I supposed to print something? Please. Okay, the first integer, the number of apples. So yeah, we increment the amount of apples. Okay. Oh, they want us to print it on 2 different lines. As a string or something? So they want us to print it, bro. So print that's actually weird. I'm pretty sure that's what they want, even though I could, like, you know what I'm saying, do it better. Alright. This seems to be a free problem. I don't know why I was dodging it, but I feel like my stats, I just have too much aura when it comes to coiling right now. Guys, it's day 10, bro. We're at double digits. I know I was gonna say I didn't do a medium problem today, but I low-key was back today. I've been saying that for the past 5 days. It's crazy. But yeah, for real though, tomorrow I'm actually looking forward to it. And you see the time. It's 11:11, right? You're about to see me go crazy tomorrow. I'm actually gonna record early on in the day, and hopefully wake up early too. And yeah, guys, thank you guys for watching this day 10. And yeah, see you guys tomorrow.